I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We are serving you for the last 15 years. There are now more than 16,000 videos, absolutely free for you to watch. Most of the questions which I upload come from you, my subscribers and viewers. Your appreciation and comments are highly appreciated. In this video, we are going to look into how to solve problems based on tangents and normals using first derivative. We have taken four examples here. The questions are before you. I would like you to pause the video, answer these questions, and then look into my suggestions. In case you want to learn from me directly, you can send an email on the address given globalmathinstitute@gmail.com. Let's begin with the very first question, which is based on tangents and normals. Question 1. Find the point at which the tangent to the curve y equals to x squared minus 2 is parallel to y plus 3 equals to 0. Now we want something parallel to y plus 3 equals to 0. Now y plus 3 is a horizontal line, correct? Now here we know that the slope m is equal to 0, correct? Now let's look into the question. So first thing is, let's try to understand what are we trying to find. Find the point at which the tangent to the curve x squared minus 2 is parallel to this. That means horizontal tangent, right? So the line given to us is y equals to x squared minus 2. The slope of the tangent can be found by using the first derivative, which is 2x, and we want this to be equal to 0. That means clearly x is equal to 0, right? So we need to find the point means both x and y values, correct? So substitute x as equal to 0, so we get y equals to 0 square minus 2, which is minus 2, right? And therefore the point, let's say, p is 0 minus 2. Makes sense, right? Well, you could visualize this very easily by sketching this graph y square minus 2, which will be a graph kind of like this, opening upwards with y-intercept at minus 2. And clearly, the slope of the tangent line at this y-intercept is horizontal, and that is what we are looking for. So you can visualize what you just got, correct? Let's move on to question number 2 now. Question number 2. Find the equation of tangent to the curve y equals to x squared plus 2x, which is normal to y equals to x by 4. So what are we looking for? We have two equations given to us. One is y equals to x squared plus 2x. Let's find the derivative of this, right? So dy dx is equals to 2x plus 2, right? This is something which we just found. Now it says, find the equation of tangent to this curve will definitely have slope like this, which is normal to the curve y equals to x over 4. Now when I say normal to the curve, so normal to y equals to x by 4, right? So let's see. What is the slope of this? Well, the slope of this line is actually 1 over 4, right? And normal slope will be how much? Negative reciprocal means minus 4. So that means we need to find the equation of tangent to the given curve, which is normal, means the slope should be minus 4 for that tangent, correct? So we'll substitute this value of minus 4 here and find the point. So if I substitute slope as minus 4, we can find what is the value of x on the curve, which is a parabola, where the tangent will have a slope of minus 4, correct? Perfect. So now let's solve for x. So if minus 4 minus 2 equals to 2x, and that gives you that 2x is equal to minus 6, or that gives you the value of x as minus 6 by 2 or minus 3. Clear? So we have found the slope of the line. Now we need to find the equation of tangents. It's important to do both the parts and understand what you need to do, right? So in this question, now let's try to write down the equation of the tangent line. So we know that we're talking about the line which is y equals to x squared plus 2x, correct? And on this point, we want slope m, which is negative 4, right? That will make it normal. And we found that the x value of the point just now calculated is minus 3, right? So x is equals to minus 3. Let's find the y value. So y equals to minus 3 squared plus 2 times minus 3, which is 9 minus 6 or 3, right? And therefore, let's say this point P is minus 3, 3. Correct. If that is the point and the slope is minus 4, what is the equation of the tangent? So now let's write down the equation of the tangent. So equation of tangent. We'll use the formula y minus y1 equals to m times x minus x1, right? Point slope form. So we know it is equal to y minus the y value, the point is 3, slope given to us is minus 4, and minus 4, right? X minus minus 3 makes it plus 3, right? You can bring all the terms together, write down the equation, right? So minus 4x minus 12, and that gives you 4x plus y minus 3 plus 12 equals to 0, or 4x plus y plus 9 equals to 0. So that becomes the equation of the tangent line. Perfect. Is it absolutely clear to you, right? So now, in the very first question, we asked for what is the point at which we have this particular slope. Now we are saying what is the equation of tangent line. Let's move on and take up the next level of question, question number 3 now. Find the point at which normal to the curve g of x equals to x squared at x equals to 1 intersects the curve again, right? So let's try to understand. Let's say we have this function y equals to x squared, which is a parabola. So let's visualize. At x equals to 1, find the point at which the normal to the curve at x equals to 1, right? So the normal at this point could be kind of like this, right? So as you can see, it does intersect the curve at another point, right? So if x is 1, x squared is also 1. So the point P, you can see, is 1, 1. We need to now find the point Q, correct? Perfect. So that's how we are going to look into the situation. So once you visualize, let's find that g of x given to us is x squared. Derivative gives us the slope, right, which is 2x. Now at x equals to 1, that means derivative of 1 will be 2 times 1, which is equal to 2. We need to find the equation of the normal, right? So the normal slope will be negative half. Now this is going through a point P, which is 1 minus 1. Clear? Now we need to find this equation of the normal. Equation of the normal, using the point slope form, we get y minus the y value of 1 equals to slope of minus half times x minus 1. Cross multiply with minus 2, right? So we could get minus 2y plus 2 equals to x minus 1. Bring them all together, right? We want to keep x positive, right? X plus 2y minus 1 minus 2, right? So we get y equals to x plus 2y minus 3. So that becomes the equation of the normal, right? So this is our equation of normal. So we have found the equation of normal. What do we really want? We want the point at which it again intersects the curve. So we want to find the coordinates of point Q, correct? So to find that, let's find the intersection of this line with y equals to x squared, right? So let's take it on the next page. The equation of normal is x plus 2y minus 3, right? So we have x plus 2y minus 3 equals to 0. And we need to find point of intersection between this and the curve g of x equals to x squared, which is basically the y value. So I'm substituting y with x squared. So we get x plus 2x squared minus 3 equals to 0. Rearrange, so we get 2x squared plus x minus 3 equals to 0. You could use quadratic formula or you could factor this out to find the possible values of x, right? So 2 times 3 is minus 6, right? And we need plus this. So we could split x squared as 3 and 2, right? So plus 3x minus 2x minus 3 equals to 0. We could factor this, taking x common. So we get 2x plus 3, right? And minus common 2x plus 3 equals to 0. So that gives you the factored form of this particular parabola, which basically is 2x plus 3, we get x minus 1. So one value of x is minus 3 by 2. The other value of x is 1, right? So at 1, we know this normal is going through. We need to find the point at which this normal intersects. So that point is x equals to minus 3 by 2. And the y value for this particular point will be what? So y will be minus 3 by 2 whole square, right? So which is 9 by 4. And therefore, we can say that the point Q is minus 3 by 2, 9 by 4. Is that clear to you? So that is how we are going to solve this particular question. Very interesting question, as we just saw. How do we find points at which the normal intersects the curve? Now, here is the very last question for you. I hope you are enjoying this journey of learning. Well, in case you want to learn from me, feel free to send an email on the address given. Watch our playlist with thousands of videos. Perfect. Question number 4 here is find equation of normals to the curve y equals to x cube that are normal to the line 3x minus y plus 7. Okay, so 3x minus y plus 7. So that is the question for you. So basically I can rewrite this particular line as y equals to 3x plus 7, right? Okay. Find the equation of normals to the curve y equals to x cubed. Let's try to sketch and understand this situation. So the curve x cubed looks like this, right? Okay. Find the equation of normals to this curve that are normal to the line y equals to 3x plus 7, right? So slope positive, right? And 3x and y-intercept of 7. So let's say this kind of a line will be there, right? Now, clearly, we could have couple of tangents, right? Normals to this curve, which could be normal to the line also, right? Make sense? So those are the points which we have to find, right? For example, let's say this, right? So this is normal to the tangent as well as the line. So that is how you have to find the points, correct? So to begin with, we know that the normal to the line, since we have a line which is y equals to 3x plus 7, we know that the slope of normal will be negative reciprocal of this, right? So minus 1 over 3. Is that part clear? This means slope is m, right? So normal will be negative 1 over 3. So that means we are looking for a point on the curve y equals to x cube, where the slope of the normal is minus 1 over 3, right? Correct? So slope of the normal is this, right? So find the equation of normals to the curve this that are normal to this line. Is that clear to you? So basically, we would like to have slope of 3 only, right? So basically, we are looking for slope of 3 on y equals to x cube. So normal will be minus 1 over 3. Perfect. So let's figure out. So the derivative is what? So y prime will be 3x squared, and that should be equal to 3. That implies that x squared equals to 1, or x is equal to plus or minus 1, right? Once you do square root, you have to take both values, plus and minus 1. So basically, at plus 1 and at minus 1, we are going to have normals which will have slope of minus 1 over 3, and they will be normal to the curve. You get the idea, right? Correct. So now we know that the points are, if x value is 1, so let's say one point P is 1, 1 cube is 1, and the other point Q is minus 1. And we also know that slope of the normal, which is mn for us, is minus 1 over 3. So let's find the equation of these two normals. So they are basically two normals, right? So we know that the normal is minus 1 over 3 slope, right? And the points P and Q are 1, 1, and Q is minus 1, minus 1. Correct. So let's find the equation using slope intercept form. Y minus y1 equals to m times x minus x1. So one equation will be y minus 1 equals to minus 1 over 3 x minus 1, right? So when I multiply with, let's say, minus 3, right? So minus 3y plus 3 equals to x minus 1. 0 equals to x plus 3y minus 3 minus 1, right? So we get one equation which is x plus 3y minus 4 equals to 0. Is that clear to you? Perfect. Now find the second equation. For second equation, we are going to use point Q. So it will be y plus 1 equals to minus 1 over 3 x plus 1. Correct. Multiplying by minus 3 will give us minus 3y minus 3 equals to x plus 1. Or writing them together, x plus 3y plus 3 plus 1 equals to 0. So x plus 3y plus 4 equals to 0. Correct. So that becomes the second equation of the normal, which is be normal to the given line also. Makes sense to you? Correct. So with that, you see, we have solved these four brilliant questions. They really help you to understand how do we use derivatives, tangents, and normals in solving questions. In the next video, we'll again take some more questions and higher level of questions which are very popular in IB test. I hope you enjoyed this journey of learning. We'll take up more related questions for your benefit. Feel free to write your comments and share your views. Thanks for your time and all the best.